Hi, welcome back to section 9.1. We decided if relations were functions based on a graph and found on their domain and range using a graph. The next thing we're going to do is decide if a relation is a function based on its equation, kind of doing an algebraic approach and finding the domain algebraically. Okay, so the first one I've got for you in example 5 is y equals negative 2x plus 7. Now, when you get something like this, you might actually know what it looks like. I mean, that's a line where it has a y-intercept of 7 and a slope of negative 2. So in your brain, you may even have a little sketch where you could think, oh, it's going through 7 and has a slope of negative 2. It's going to be this diagonal line that looks about like that. So you may even be able to do a visual of it. But let's say that you just want to approach it algebraically. So if you want to decide if it's a function, you have to decide if you input an x value, how many y's will you get? So if I put in a number with x, I'm going to take that number and I'm going to multiply it by negative 2. Well, multiplying by negative 2 doesn't give me two different answers or anything like that. It would just give me one answer. And then if I take that and I add 7 to it, well, adding 7 also just gives me one answer. So basically, no matter what x value you put in, you're just going to get one y value as a result. And if you want to try it, sure, you certainly can. Be like, well, what if x is 1? Well, you do negative 2 times 1, which is negative 2. And then negative 2 plus 7 would give you positive 5. And so you would have the 0.15 as an answer. And so you could do this as many times as you want to until you feel comfortable with it. But basically, every x value that you put in, you're just going to get one y value, and that makes this a function. Okay? For the domain, what you're thinking about is which x values get used, or are there any restrictions on your x values? So anything that I put in, I can multiply by 2. It doesn't really matter which x value I put in. Anything can get multiplied by negative 2, and anything can have 7 added to it. So there's no restrictions at all on my x value, which means that every x can be used and does get used. So your domain on this one is going to be all real numbers, which in interval notation is negative infinity to positive infinity. If you have that sketch in your brain, you can also think, how far left does it go? Well, it keeps going forever in that negative direction. That would be negative infinity. How far right does it go? It keeps going forever in that direction, which would be positive infinity. And we always use parentheses with our infinities. Okay? Let's look at the next one. So in B, we've got y to the 4th equals x. This one, you may not have a good picture of what it looks like. It's not a line like the last one. We've got y to the 4th equals x. And so then you have to think, well, if I put in an x value, how many y values am I going to get? Am I just going to get one, or could I get more than one? And so you may even think about, what about an example? How about if x is 1? How many different y values could we get so that x is 1? Well, this time, really that operation is on the y's instead of the x's, and so it's kind of a little bit backwards from normal. And so, well, y could be 1, right? 1 to the 4th is 1. But what about negative 1? Could y be negative 1 since it's an even power? Well, negative 1 times negative 1 times negative 1 times negative 1. If you multiply negative 1 by itself 4 times, you actually get positive 1. And so if x is 1, you have two different y values. And that's going to happen throughout, is that whenever you put in an x value, there's going to be two different y values for most of those x's. The only exception is 0, because 0 to the 4th power is 0, and so you don't have that positive or negative for 0. So basically, a lot of our x values are going to two different y values, which means that this one is not a function. All right, next up, let's think about that domain then. So the domain is which x values get used. And since the operation is on our y's, it's not any x value can be x. Well, I have to think about which x values I'm going to get if I raise y to the 4th power. Well, you're noticing anything raised to an even power, it's kind of like a y squared. it gives me positive values no matter what I put in for y. Just like if I put in that -1 to the fourth, I got a +1. So if you put in a negative value or a positive value, you get a positive x. So our x's are going to be all of the positive values, okay? So then if I think, well, how do I write that in interval notation? How do I write all of the positive values? Well, our smallest positive value that we could get would be 0. 0 is positive and negative at the same time. And the largest, it would just keep going until we get to infinity. It can include 0. We kind of talked about 0 could be a point. We'd have the point 0, 0. Infinities can never get included. We'll use a parenthesis with the infinity. So that's how you kind of approach these algebraically. Now it's your turn. You guys get to try one and show me how much you've learned.